the chat window. There's a chat icon in Zoom that you can use. So if you can just park your questions in the chat window, and at the end of it, I can unmute each of you one by one, and we can discuss your queries. Okay. All right. So let's get started with the session. It's good to see such a large turnout on a Monday morning, and let's make it a fruitful session. Okay. So quick check, is my screen visible? Just let me know if my screen is visible. GUVi, can I get a confirmation from your side in the chat window? Okay, great. So we'll get started. All right. Thanks. All right. So welcome everybody. Morning, very nice and bright Monday morning to you. And let's start with our session. So we'll be covering some basics of blockchain, and we'll be looking at what are the career opportunities that you can consider while working in the space of blockchain. Let me start with a small introduction of myself, and this is a basic timeline for today's session. We'll be looking briefly at blockchain technology and why it is so popular right now, why so many industries are working with it. And okay, is there a problem with the audio? Are you guys able to hear me? Is there a problem with the audio? Okay, so people who are not able to listen, I think just check your internet connection. Okay, so sorry for the interruption. Let's get started. Right. So this is our roadmap for today's session. I'll start with a brief introduction of myself to set the context, and you have some idea about who is the person on the line who is talking about blockchain. We'll look at briefly about blockchain technology and why it is so popular right now, and why so many industries are working with it, why governments are working with it. Next, we'll cover some basics of blockchain. So what is it under the hood? What is the mechanism that makes it tick? What are some of the important concepts in blockchain that you might want to look at? And we'll close by discussing the career opportunities that you can consider. Okay, right. So to introduce myself, I am Ishan Roy. I head the blockchain initiatives of Tamil Nadu e-governance agency. So we are a trust under the IT department of Tamil Nadu. We are essentially like a emerging technologies consultant to the Tamil Nadu state government, and we work with multiple emerging technologies such as AI, blockchain, drones, IoT, etc. So the blockchain projects are being headed by me and my team. One of our largest projects is something called Nambike Inayam. So it's called the Tamil Nadu statewide blockchain backbone. And the idea is that we are trying to build a blockchain network that will connect all the government departments of Tamil Nadu and can also be used by the private sector in the future, hopefully, right? So that's briefly about what I do and who I am. I've had a lot of experience in the BFSI sector in blockchain, specifically in the areas of payments, cross-border remittance, trading, exchanges, etc. I used to work as a part of the blockchain team at ICICI Bank. This was the team to conduct the first banking blockchain remittance transaction in India. This happened in the year 2000. Yeah, yeah, yeah. Thank you. Yeah, sorry about that, guys. I'm not sure what happened with the internet connection here. I dropped out because I'm connecting from home. Yeah, just a moment. Okay, yeah. So going back to where we were. So I used to work with ICICI Bank's blockchain team, where I was part of the team that conducted the first banking blockchain remittance transaction in India. And after that, I started up with my teammates and we opened a startup called Hashcash Consultants LLC, where we were building fintech products using blockchain for a lot of banks, remittance exchanges, small and medium enterprises, etc. I've also authored my own book called Blockchain Development for Finance Projects, and it is available through Pact Publishing. Okay, right. So let's get started with our topic for today. Right. So let's set the context first. So let's understand what this technology is and why it's so popular right now. So as a lot of you might know, so the word blockchain or the blockchain technology, it was first invented as the backbone for the Bitcoin cryptocurrency network. And the idea was that they wanted to create a peer-to-peer ledger where the various records that are captured in this infrastructure, they are linked using cryptography. So we'll briefly discuss what a peer-to-peer ledger is and how they are linked using cryptography. And the term was first coined by a gentleman or a woman called Satoshi Nakamoto in their white paper Bitcoin, a peer-to-peer electronic cash system. So Satoshi Nakamoto is the founder of Bitcoin and also the father of blockchain. We actually don't know who Satoshi Nakamoto is. That's an anonymous individual. So it could be a man, it could be a woman, it can also be a group of people. So the founder and the creator of blockchain is essentially an anonymous person or entity. So before we jump into what blockchain is and what are the mechanics, let's understand what a peer-to-peer ledger is and why it is required for for today's enterprise systems, right? So consider this case study. So let's say you and your friends have gone out for a party and you end up spending some money from your pockets, right? So let's say somebody is A over here and they spend 200 rupees on buying, or let's say a cab, okay? Then B spends 100 rupees on, let's say, movie tickets, and C spends 300 rupees on dinner, right? So typically what will happen is after your outing, A, B, and C, you will come back, you will sit together, you will do some back of the envelope calculation where you will see, okay, how much I have paid, how much the other person has paid, and what is the total expense. Then you will come together, you will compare your records, and then you will come to the conclusion that, okay, total we have spent 600 rupees. So ideally, each of us has to pay 200 rupees each. So that means B has to pay 100 rupees more and C will get that 100 rupees, right? So this calculation typically we do after we have a party or outing, right? So this process where you come, you do some calculation and you check, you do a basic accounting and you check how much money is owed, how much needs to be paid. So in finance, this process is referred to as reconciliation, right? So typically you will heard banks say that, oh, we have an operations team that does reconciliation, or we need to do reconciliation for our payment system. So that is referring to this process. In when the amount is low, you or when there are less transactions, you can do back of the envelope calculations. However, let's say if you are, sharing a flat with your roommates, or if you're sharing expenses with your wife or family members, typically this back of the envelope calculations becomes difficult. So you might go for an external app like Splitwise, right? So Splitwise is like a popular app that a lot of us do, and Splitwise also essentially does the same thing. So it will capture the various inputs, or it will capture the various spends that you're doing, and then at the end of the month it will do a calculation and let you know how much money is owed, how much you need to pay to the other person. Okay, so this process that happens, this is called reconciliation, and sometimes we do it ourselves using a back of the envelope, and some other times what we'll do is we'll use an external party or an external app called like Splitwise. Okay, so now the problem is that when it's individuals or when it's less money, it's acceptable to carry out this process like this. However, if I talk about large firms, so let's say if I'm talking about Reliance Industries Limited, if I'm talking about FedEx, and if I'm talking about Walmart. So they cannot do this process, right? For them, it will be quite a cumbersome process to do this reconciliation like this. So let's say Reliance, FedEx, and Walmart, they enter into business with themselves, and for some initiative, Reliance spends $200,000, FedEx spends $300,000, and Walmart spends $100,000, right? And let's say it's a equal partnership where all of them were supposed to spend equal amounts of money. So any extra money that has been spent, that needs to be offset. So basically Walmart needs to pay more and FedEx needs to pay less, right? So if you have a situation like this, Reliance, FedEx, and Walmart, if they go for a back of the envelope calculation, or if they try to reconcile their accounts, it is typically done through a scheduled batch process, right? And it's extremely expensive, it's extremely time consuming, and it's prone to errors. So what will happen is that Reliance's accounting vertical, they will sit, they will look at, okay, what is the expense that has been done, how much we need to pay, how much money needs to come in, what is the date it needs to be paid at, right? So it's a very expensive, time consuming process, because you'll need to hire a bunch of people. They'll sit, they'll take all the calculations into account, and then they'll split up a number. Then similarly, FedEx's team will also do that. Then Reliance and FedEx will come together, they'll exchange notes, and they'll see, okay, our records match, so that means we both agree on the statement that Reliance needs to pay FedEx, or Walmart needs to pay FedEx, whatever, right? So it's a very expensive process, it's a very time consuming process, and it's extremely prone to errors. Alternatively, what they could do is they can go for a middleman. So basically they can have something like splitwise in between, where they feed in their transactions, and this app will, or this infrastructure will tell them that how much money needs to be paid to each other, so that they are able to settle their books. But obviously with that, the problem is that you're trusting a middleman, or you're trusting a central entity who will get all your data. And in such a situation, that data is at the risk of being leaked, or somebody can sell it to your competition, or it can be somebody can modify it, etc., right? So it's quite cumbersome to do it the way that individuals do it, and we need a more robust process. We need something that's more fast and efficient and less expensive to fast and efficient and less expensive to solve this problem of reconciliation, or matching books between the individuals. So what are the various options that are available to the enterprise? So the first thing that they can do is just, okay. So the first thing that they can do is they can place trust on a central authority who will get these transactions from them, who will basically match these accounts, and who will tell them how much amount needs to be paid, right? So typically this will happen when you look at how payments happen. So for example, if I am a customer with Axis Bank, and you are a customer with SBI, and I need to send you money. Okay, so what I'll do is I'll submit a payment transaction to Axis Bank. Axis Bank will then go to a middle intermediary, which is a body called NPCI in India. So National Payment Corporation of India. So Axis Bank will go to NPCI, and it will notify SBI that there's an incoming transaction. SBI will then take the incoming transaction and credit the beneficiary. Okay, so in this case, the intermediary is NPCI. Similarly, if you look at how something like payments happens between banks using Visa or MasterCard, right? So my merchant can have a different account with, let's say, HDFC or Citibank, and I can have an account with ICICI Bank. And typically Visa or MasterCard is the intermediary who is acting as a middleman to route these transactions from me to the merchant's bank, right? So what they are doing is they are basically doing this process where they are settling these accounts. They are essentially capturing the data from both the parties and showing them how much needs to be paid to settle the accounts, or how much money is going through. So typically in these cases, to solve this problem, you place the trust on a central authority. But obviously, if you place the trust on a central authority, and the central authority is a commercial entity, or if it's not somebody who is trusted, you can land into a bunch of problems. So for example, for going through Visa and MasterCard, merchants and customers, you have to pay a certain transaction charge to Visa or Mastercard, which typically gets very large which gets very large when the transaction amount is large. Similarly, if let's say in a country or in a geographical area where Visa or Mastercard is not present, I can end up with a situation where I can say, just a moment, guys. So in a situation where Visa or Mastercard is not present, I can end up with a case where I end up trusting a middleman who is not very trustworthy, who can run with my money, right? So, for example, if let's say I am trying to, I'm trying to sell a car in a certain geography, and somebody is trying to pay money for my car, and we both don't trust each other, we might end up with a situation where, why is this annotation happening here? Anyway, so we might end up with a situation where we end up trusting somebody who's not very trustworthy, right? So they might run away with my money, they might run away with my car, right? So there's a risk over there where I place trust on a central authority. So the idea behind blockchain and the idea behind building a peer-to-peer ledger is that, can we build a system where I don't need to trust a central authority, and still I'm able to efficiently balance my accounts. I'm able to efficiently balance my accounts and carry out transaction between multiple parties in such a way that the trust is not violated and I don't need to place trust on a central authority. Okay, just a moment. Yeah, GUVi, any idea how I can shut this annotation thing? Because why is this thing happening? Uh, Hi GUVi, is there any way I can shut the annotation off? It's extremely irritating. I'm not sure how it's happening. Anyway, I think we'll just ignore that. Right. So that's the idea. How do we build a system where we don't have to depend on a central authority and we can carry out such transactions, right? So if basically this is what it says, that if there is no regulator, if there's no trusted authority in between, and I just go for any middleman, there's a chance for cheating happening. Somebody can walk away with my money. And there's a lot of associated costs and time delays with this thing, right? So if you look at cross-border remittance, if you look at how money is being sent from, let's say, a bank like JP Morgan to India, there is no central authority there. In India, if I'm sending money from Axis Bank to SBI, I have NPCI, which is a central authority, and they can help me coordinate the transaction. They can help me ensure that nothing fraudulent will happen. However, when I'm carrying out cross-border remittance, there's no central authority that is there. Okay, so that is why you will see cross-border remittance today is very expensive. It is time-consuming, and the way it happens, it's extremely cumbersome. So, in cross-border remittance, that is why blockchain is considered to be such a good uh, technology that can be used to solve these problems. So some of the examples where blockchain is being used is, for example, TRAI, if you have heard of this. So typically when you port your mobile number from one service provider to the other service provider, your do not disturb, your DND settings, they get revoked and you have to apply again. So what TRAI is doing is that, Telecom Regulatory Authority of India, they're telling all telecom companies to create a blockchain network between themselves, so that when a customer moves from one service provider to the other, his DND settings are preserved. So you don't have to apply for DND again and again. The reason TRAI is doing that is because they don't want to be an intermediate and hold a database with these settings. That is why they are asking all these companies to do that using a peer-to-peer network and a ledger. Similarly, RBI has recently come up with this platform called Threads, TREDS. So what Threads does is that basically, if you look at how loans work in India, so let's say if I am an entrepreneur and I am exporting some goods to outside to Europe or something, and if I need to take a loan from a bank for building these goods, so what I'll do is I'll take the purchase order or the work order that is sent in by my client. I'll go to a bank and I'll say that, hey, I have an order for $100,000. Can you please give me a loan for $60,000 so I can take the money and build my product, and then I'll pay it back to you. So what some entrepreneurs do is that they'll take the bill and they'll go to multiple banks and they'll show the same invoice and take multiple loans. So instead of picking up $60,000 from the market, they'll end up picking $120,000 or $180,000 from the market using the same invoice multiple times. So ideally, to do that, banks should know that a loan has been issued across this invoice. Uh, Traditionally, it is done through CRISIL's platform, but the way CRISIL works, it takes 15 days for that information to be uploaded to the system. So through a central database, through traditionalized norms. So in that 15 days, there's a risk of somebody carrying out this fraud where they can take an invoice and take money from different departments. Hello. Yeah, the screen was shared just now. No, what? It's not visible, kya, the screen? When did I thought the screen was shared? Okay. Yeah. Yeah. Is the screen visible now? Are you guys able to see? Right. So, like I was saying, so Trades is a platform by RBI where what they will do is that instead of waiting 15 days for these invoice to go to CRISIL, they will take the invoice and they'll upload it to this blockchain platform. And if somebody tries to commit any fraud, somebody tries to take the invoice and raise take multiple loans across it, immediately is notified because it's a peer-to-peer network between all the banks, and all the banks have visibility of how many loans have been issued across an invoice. Okay, so this is something that has gone live recently, the Trades platform, and where they're using blockchain. Okay, so this is typically how a peer-to-peer ledger would look if you remove an intermediary or if you don't do scheduled reconciliation between the participants. So you would end up with something like this where there's a ledger that is maintained across each participant. So you will notice that there's this copy of transactions that is maintained across each participant. In each ledger, all the transactions that are carried out between the participants are captured. Okay, so for example, Reliance sending money to FedEx, Walmart sending money to FedEx, Reliance sending money to Walmart. So any transaction, all of them are captured in this ledger and stored in all copies of the ledger. Even if, let's say, in Reliance's copy of the ledger, Walmart and FedEx's transaction will always also be captured, because you need a holistic view of the system. You cannot just have your transactions, right? You need a complete view of the system so that you know if somebody is trying to commit any fraud or if some settlement needs to be done, right? So typically what we do is we set up this peer-to-peer ledger where anytime someone submits a transaction, that is broadcasted to all the ledgers in the network, so all the participants in the network, and that way everyone has a transparency where they're able to see what are the transactions that are carried out, and they're immediately able to detect any fraud. So this ecosystem is called a peer-to-peer ledger, where you have a copy of the ledger with all the participants, and anytime a transaction is posted, it is broadcasted to all the participants in real time. Everyone has a visibility. In a system like this, there's no requirement for reconciliation, because in our previous system, what we were doing is we were maintaining data in silos. So they were separate from each other. We were coming together, doing calculations, and we were coming to a conclusion on how much money needs to be paid or received. But in this case, this calculation happens in real time. So anytime I post a transaction to the ledger, automatically it is calculating how much money needs to be paid, how much needs to be received, etc. Okay. And lastly, how the system works is that the three copies of the ledger, they are constantly in sync. So anytime a transaction is posted to, let's say, Reliance's ledger, it will automatically get broadcasted to FedEx's ledger and Walmart's ledger. So the copies of the ledger will always be in sync. They cannot be different from each other. And if somebody tries to tamper with it, or somebody tries to remove something that is already added, the system will prevent that. Okay, so this is the concept of a peer-to-peer ledger, and this is why we use blockchain, or this is why we consider peer-to-peer ledgers for building enterprise applications. Okay, so this is briefly just a background of why blockchain is, or why the peer-to-peer ledger concept is so important, and why enterprises are looking at using this. Now, there are multiple applications apart from finance where this peer-to-peer ledger can be used. The first is I can use it for asset provenance. So what does asset provenance means? So in our case, we were looking at money as it moves across various participants. So it can be US dollar or Indian rupees or euro, etc. However, the asset can be something else as well. So let's say if I have individuals who are buying and selling land, right? And I want to maintain I want to maintain this proper record of ownership of the land. So I can use a system like this between the participants, which is monitored by the authorities, which keeps a track of who is the real owner of the land, right? So similarly, asset can also be something like, let's say, diamond. So if you look at how diamond is mined, and then it's processed, and then it is used in jewelry or something else. So typically diamonds are will be mined in something like Africa, South Africa. Then it will be sent to Surat in India for processing, for polishing the diamond. After Surat, it will typically go to China or America, where it is finally finished into jewelry and sold, right? So this asset provenance as to how diamond moves through the various participants, this is extremely important to track fake diamonds, or to eliminate any diamonds that may come from unethical means, such as blood diamonds. So there also blockchain is a great use case. In fact, a lot of enterprises are using it for cases like this, for asset provenance, where you check that where a diamond has come from, and you keep a track of it as it moves between participants. Similarly, asset provenance can be used for, let's say, something like identity as well. So if I can issue you your driver's license, or I can issue you your social security number or Aadhaar card on a blockchain like this, and somebody who is verifying your identity can see that it has been provided to you by a central or state government authority and signed by them. Right. So the first thing is using it for asset provenance, for things other than money. Other than that, you can use it for storing document hashes or document signatures. So why this is prominent is that in a lot of applications, what we are doing with blockchain is that, let's say, with something like certificates, or with something like ID cards, or with something like contracts and agreements, we have realized that there's a need to identify that a document is unique, and we somehow need to capture a unique signature or something that's unique about the document, and store it safely in a place where it cannot be modified, right? So to do that, what we do is we take the digital copy of the document, and we calculate its hash signature. So a hash signature is basically like a unique identifier for a document, and it is stored in a blockchain network between the participants, so that it cannot be modified and everyone is able to track it in real time. So if I talk about the case of diamond that we were discussing earlier, so while we are tracking a diamond as it moves from Africa to Surat to China, etc., let's say we also want to issue a certificate to the diamond as authenticity, and we want to store it, and we want to ensure that it's not manipulated, or somebody cannot issue fake certificates. So one thing we can do is we can generate a certificate for the diamond, and we can store its hash signature or any other unique identifier in a blockchain network between the manufacturer, the retailer, and the company from which it was mined. And if a customer needs to check if their diamond is valid or not, they can simply verify the certificate against a network like this. So this is the case where you use document hashes, or for something like education certificates, where, let's say, I need to prove that I am a authentic student who graduated from IIT or Anna University, etc. So government officials can issue me my certificate, and they can capture a hash signature on the blockchain to verify the authenticity of the document. In case I apply for higher education or for a job somewhere, the employer or the education institute can come back to the blockchain and verify that this certificate was issued by the right authority. Similarly, we can also use a blockchain to store some metadata or information that we might want to store. So, for example, in the diamond case, I'm going back to the diamond case again. So, let's say some information about the diamond needs to be stored that can be referred to again and again in the future, and it should not be tampered. So, let's say how many carat a diamond is, or what is the weight of the diamond. So, things like this can be stored along with the provenance of the diamond, and since it's a peer-to-peer network and it cannot be changed, once that information is captured about the diamond, it is valid for the entire history of the blockchain and the entire history of the diamond. So in the future, if there's a doubt about how many carats the diamond is, or about what was the weight of the diamond or where it was found, that controversy can simply be removed by going back to the blockchain and checking that what was the initial carat that was issued to the diamond, or what was the initial weight, or where was it mined initially. So this peer-to-peer ledger can be used for multiple applications. Okay. So with that, was a brief introduction to how blockchain is being used and why a lot of enterprises and governments are so interested in checking out this technology. Next part, what we'll do is we'll discuss some basics of blockchain. So we'll look at some concepts you might have heard of when you hear people talking about blockchain. So we start with the concept of a peer-to-peer network. So let's look at what a peer-to-peer network is basically. So a peer-to-peer network is essentially a network where you have different participants running some sort of software or application on their system. And this software or application is connected to each other either through internet or intranet, right? So if you have used torrent, that's the example of a peer-to-peer network. Or if you have used some other type of file sharing network. So these are peer-to-peer networks where you run an application on your desktop or your system, and you are immediately connected to the other participants in the network. How this differs from a client-server model is that typically when you use an application, or let's say if you use something like Paytm, so there will be a client side and a server side. So when you launch your Paytm app, that's like a client application, and that is making requests to a server that is somewhere. So the server is basically handling all the requests that you are sending to it. So if you say send money, so the server will basically serve you, it will carry out that operation for you. If you say show me my balance, so the server will carry out that operation for you. So that's a client server model. How blockchain works is it works in a peer-to-peer model where you don't have a client and server like this, and everyone has a similar designation. So everyone runs the application and they're connected to each other on the network, and this network can be either internet or intranet. The smallest unit of a peer-to-peer network is this circle, which is called a node. So a node is nothing but the smallest computing unit of a peer-to-peer network or a blockchain unit. Basically what it means is that if you run a Bitcoin application, if you run a Bitcoin wallet, or if you run any blockchain application, and you host the ledger on your system, then you are a node on the peer-to-peer network. Okay, so these are some terminologies that come up, and a node and the internet protocol is the basic building block of a blockchain network or any peer-to-peer network. Everything is built on top of this. So there can be different types of peer-to-peer networks that exist. So you can have a permissionless network where anyone can launch this application, install it on their system, and connect to the network. So for example, if you've used uTorrent, you don't need some sort of permission from the participants to connect to the Tor network, right? So this is an example of a permissionless network. Similarly, if you've used Bitcoin, you don't need any permission from the participants to join the network. So this you can simply run the Bitcoin application and connect to the network. So this is an example of a permissionless network. A permission network is where you need the participants' permission to connect to the network or carry out certain operations. So for example, if you look at how we as a government are implementing blockchain networks, or how enterprises implement blockchain network, typically you cannot join to these networks readily. you need to ask the permission of the person who is running the network or of the other participants. So these are called permission networks. You also have semi-permission networks where certain operations you can carry out, but for other operations you need permission from the network participants. So for example, there's a blockchain network called Stellar. So you can connect to the Stellar network, you can submit transactions, you can carry out transactions, you can view transactions as well. But to run a full node, so basically a node that does some verifications on the network and has some administrative control on the network. So to run that full node, you need the permission of Stellar's organization, the people who are running the network or other large participants on the network. So this is a semi-permission networks where certain features you can carry out without permissions, but for certain features you need to ask permission of the participants of the network. Networks can also be divided into public and private networks. So public networks are networks that are visible to everyone, they can join. Private networks are typically behind a firewall, so not anyone can readily join. It's only visible to the participants who are supposed to connect to the network. Okay, now another concept we'll be discussing is the concept of consensus, which again you might have heard. So when you build a peer-to-peer ledger like this that we were discussing, very soon you will run into a problem. So the problem is that now that I've got so many copies of the ledger and everyone is adding transactions to it, how do I, how do I sequence the transactions? Because there are so many participants and there are so many copies of the ledger. How do I decide which transaction gets written to the ledger, and how do I ensure that all the ledgers are uniform? Because in something like a centralized database, it's easy, right? So everyone submits transactions to write to the database, and there'll be a batching system or a queuing system that will queue all the requests and then implement it to the database. So that's easy because there's a single copy of the database. But in this case, I have multiple copies. So how do I ensure that all the ledgers are updated in sync and they remain in sync? So to do that, we use something called a consensus algorithm. And very simply, it's a mechanism to pick a writer for the shared ledger. So it's a way in which you choose who gets to write to the ledger, right? So typically what happens is that a participant is chosen from the peer-to-peer blockchain network and he gets to write to the shared ledger. The way the participant is chosen it can vary. So sometimes, like in a Bitcoin network, there's a cryptographic puzzle that you need to solve, and the person who solves the cryptographic puzzle, he gets the right to write to the network or to submit a transaction to the network for the next 10 minutes. Okay, so the way in which the participant is chosen can vary. In Bitcoin, like I mentioned, there's a cryptographic puzzle. In the enterprise blockchains, there are other methods. So for example, randomly you can choose a participant from the network. So if I build an enterprise blockchain between different banks, what I'll do is I'll carry out something called a round robin, where I'll say that first it's your chance, then it's your chance, then the third bank, then the fourth bank, and then the loop will repeat again. So the participant is chosen from the various participants from the network who can write to the ledger, and typically they have a window in which they can submit their transactions to the ledger. Once their transactions are submitted to the ledger, they are broadcasted to all the other participants in the network, and they update their ledger in sync with all the transactions that have been added. Okay, so this process, this way that this is carried out, it is referred to as a consensus mechanism, which basically allows you to update which basically allows you to determine how the different copies of the ledger should be updated. You must have heard of a term called miner in Bitcoin and Ethereum. So you must have heard that Bitcoin mining is happening. Bitcoin mining uses a lot of energy. So this miner is nothing but this writer who gets the opportunity to write transactions to the ledger. And in the case of Bitcoin and Ethereum, how they get that chances, they have to solve this puzzle that is there, this cryptographic puzzle that is there. And the person who solves it first, he gets a chance to write to the ledger for 10 minutes. After 10 minutes, a new puzzle is floated, and again, everyone tries to solve the puzzle. The person who solves it first gets to write to the ledger for the next 10 minutes, and so on and so forth. The process continues. So this concept is referred to as consensus mechanism. There are multiple types of consensus mechanisms that exist. Some of the popular ones is the first called proof of work or POW. So this is typically used in Bitcoin and Ethereum, and you must have heard that people are burning energy, or people are running these huge ASIC systems that use video cards for mining. So these are systems that use proof of work, where you need to solve a cryptographic puzzle, and the only way you can solve this cryptographic puzzle is that you need to it's similar to a dictionary attack in a way, where you have to randomize and try different results to see which one works. So this is called proof of work. Proof of stake is a modified version of proof of work, where importance is given to network participants, and what we do is we try to make the puzzle a little easy for a few participants who we think want to do well for the network, who are ambassadors of the network. And the reason we do that is because we want to bring down the energy consumption of the network. So we want to bring down how much electricity is being consumed by the network while it's operating. So if you have heard of something called Ethereum 2.0, so Ethereum is now moving to proof of stake, and they're trying to use this consensus mechanism, which is a modified version of proof of work. In enterprise, one of the oldest consensus mechanisms we have been using is something called round robin. So around 3-4 years back, we had this blockchain technology stack called multi-chain that would use round robin consensus mechanism. What this basically means is that there's a round where everyone gets their chance to write to the ledger. After the round finishes, you again start from the first participant. So everyone gets one chance to write to the ledger. In enterprise, we also use ordering or queuing mechanisms for consensus. So typically, these are used by Hyperledger Fabric and Corda and a few other enterprise blockchains, where what they do is that they run a participant called the orderer, whose only purpose in the network is to order the transactions that are being added to the network, and no one else gets to write to the network or to the ledger except for the orderer. The orderer will collect all the transactions from the participants in the network, order them in a certain way, and then write it to the ledger. Okay. And lastly, you have PBFT, called Practical Byzantine Fault Tolerance, which is basically a consensus algorithm that comes to us from older peer-to-peer networks, and they have been used for quite some time. Okay, so PBFT is not as secure as some of the other consensus mechanisms that we discussed, but it's much more faster. So typically you will see a lot of blockchain systems that focus on payments. They use PBFT based consensus mechanisms. So Byzantine fault tolerance based consensus mechanisms are being used there. Okay, so this is a brief snapshot of what are the various platforms that are using different consensus mechanisms, right? Okay, so now moving on. So now let's briefly discuss how does a blockchain store data, and why is it called a blockchain anyway? So where does the name blockchain come from? So typically how a blockchain works is that data is stored in blocks in a ledger. So what that means is that when you have this writer that you have selected through a consensus mechanism, who has a window to submit his transactions to the ledger, he will not submit his transactions one by one. He will take all the transactions that he wants to submit and submit it as a block to the ledger. So the ledger is updated at one go with, let's say, a block of 10 transactions or 12 transactions or 15 transactions. Okay, so this block of transactions that is submitted by the writer, it will have two parts to it. So there's a format to it. The first part is something called a header, which contains some information about the block. So we'll discuss what information is stored in the header, but it basically contains some metadata and description about the block and the transactions that are being added. And the second part of the block is the body of transactions. So what are the transactions that are being added in the block? Okay, and we'll look at a sample block also shortly. So let me just open the sample block so that I'm able to show you what a block looks like. Let me just show you a sample block and what it looks like. Okay, So this site called blockchain.com, this is basically an overview of the various blocks that are there in the Bitcoin blockchain. This is block number 6. This is block number 62818, okay, of the Bitcoin blockchain. These things that you view on the top, these are essentially the block metadata. So these describe some features about the block. So for example, it says the number of transactions is 2705. You know, this is the hash signature of the block. This is the version of the Bitcoin application from which the block was created. It tells you the size of the block in bytes. So you know how much size is it consuming. It tells you the transaction volume. So how many Bitcoins are being sent in this block, and so on and so forth. Okay, so this is called the header of the block. The second part of the block is the transactions. So these are essentially transactions that are happening between Bitcoin accounts. So you will notice first transaction, second transaction, third transaction, and so on and so forth. So these are two parts of the block, and this is how data is updated and to the shared ledger, and how it is stored in the Bitcoin or any other blockchain. Similarly, one of the things that you will notice between the various blocks is that for each block, if you check the header, it will give you some information about the previous block that it is referring to. Okay, so what this means is, if you go to the block header, let me see if I'm able to show it to you. Just let me just open this block. Let me just open this block so I'm able to show it. Okay, so in the header of each block, this is again, this is another application that I'm viewing through, but it is basically showing me the same thing. So this is another Bitcoin block. This is the header with block information, and these are the transactions that are there. Okay. So for every block, you will notice that it has the hash of the previous block. Okay, so this is stored as part of the block in the header itself. Why this is important is that it creates a chain between the different blocks that are there. Okay, so because this signature is unique for each block, it's a hash signature, it cannot be modified, and it will always point to the previous block. So as a result, you have a chain between the various blocks that are there in a Bitcoin blockchain. So or any other blockchain for that matter. So every block header will point to the previous block, and that way you get a linkage between the blocks that are there. Okay, that way you get a linkage between the various blocks that are there. Just a moment. Okay, so this creates a linkage or a chain between the different blocks in the system. So the way it is being stored. And this is why we refer to the system as blockchain, because you have got blocks in which the data is being stored, and you have a linkage between the various participants, with each block pointing to the previous one. Hence, we refer to this technology as blockchain. It's basically a chain between the various blocks, and that is how data is being stored between the different participants. Okay, now this chain, this block and chain that is there, it is stored across all the nodes of the peer-to-peer ledger, and they're constantly syncing to ensure that all the data that is stored and the format in which it is stored, it remains constant across all the participants. Okay, and why this is important is you must have heard of a term called immutability in blockchain. So this is where the term comes in, because if I try to change any block in this blockchain network, if I try to change, let's say, the third block, immediately the rest of the network will prevent me from doing that. It will cut my node off from the peer-to-peer network. Okay, and it will force me to sync with the rest of the network. Otherwise, I cannot process any transactions. I cannot submit any new transactions to the network. Similarly, if let's say I try to change the order of the blocks, I try to move this block over here, there will be a mismatch in the hash signature, right? So the system will immediately tell me that the order of your blocks is different from the rest of the network. So you cannot go ahead. You need to have the same format as everyone else. Okay. So this is basically some information about how does a Bitcoin, what's a blockchain block, and how do they store data, and why it's referred to as a blockchain. The last concept we'll be looking at is the concept of smart contracts, which you must have heard multiple times of people talking about how smart contracts are very efficient and how they can be used. So what smart contracts are basically are, they are self-executing workflows that depend on a certain event to trigger. So why this is important and why this is different from other business workflows or other business applications is that because it's a workflow that is spread across the participants and it cannot be modified. So what that means is, until now in our peer-to-peer ledger, we were just storing data and information. So we were storing like information about money, we were storing information about assets or some document or diamonds, etc. In this case, what we are doing is that we are taking compiled code and we are storing it to a peer-to-peer ledger. And this compiled code has some business logic stored into it, which will execute at a certain point of time. Why this is important is that the business logic that is stored, it cannot be modified. So let's say if I want to create a digital insurance scheme where I say that you pay you pay a certain premium to my insurance scheme for 10 years, and after 10 years I'll give you certain amount. So let's say if you pay me 1,000 rupees per month for 10 years, and at the end of 10 years I'll give you, let's say, 10 crores or something, okay, to your account. I can simply code it into a business logic, deploy it into the blockchain, and the code will always execute. Even me, the person who has written the code, I cannot change it. Okay, so in places where this trust deficit is there, where let's say certain people are not agreeing to a certain contract, or let's say you have an insurance scheme where the insurance provider is not giving you the payout, or if you are trying to buy and sell a car and you have paid the money but you're not getting a car. So in situations like this, smart contracts are extremely useful because you can write workflows where automatically the event that is supposed to happen will happen, and it cannot be changed once the code is modified and deployed, and that is very important, right? So briefly, these are self-executing contracts or self-executing workflows that trigger when a certain event happens, and there's no way to modify this event. There's no way to stop this event from happening. So we can just look at a small example to see how smart contracts work. So let's say Alice wants to buy a car from Bob. Okay, and Alice is willing to pay $2,000 for it, and Bob has a vehicle which he will give to Alice. Now Alice says that I'll only buy your car from you, Bob, if you get the pollution check and maintenance done from the car, and only then I'll pay you the money. Now Bob's worry is that if I get the maintenance check and the pollution check done and I spend some money on that, and Alice refuses to buy the car, my money is lost. So how do we go ahead with this transaction? So what they can do is they can write a smart contract where they will say that, they'll code it in such a way that Alice's money will flow to Bob, and Bob's car's registration papers will flow to Alice after Bob submits the pollution check report and the maintenance report of the vehicle to the smart contract. Okay, so they will write a smart contract and deploy it to the network. Alice will send her money, so $2,000, to the smart contract address, which will store that money, and Bob will send his registration papers to the smart contract, which will store the registration papers. Now Bob will go get his car maintenance done and pollution check done, and he will share these documents with the smart contract. The smart contract will do some verification, and it will ensure that the car has been maintained and the check has been done. Then it will send the documents to Alice, the car ownership documents to Alice, and it will send the funds to Bob. Okay, so this is basically how a smart contract workflow works. It's a automated workflow where you are essentially replacing a middleman or an intermediary or a trusted authority with code. with a program that will carry out a task like it's supposed to. Okay, so these are what smart contracts are, and these are what they are supposed to do. So briefly, let's close with what kind of use cases can you look at if you're working with blockchain. So there are a bunch of use cases that everyone has been working on, and I mean, broadly, you can look at it as, for example, loyalty schemes are there, insurance is there, regulatory reporting is there, where we are looking at cross-border remittance use cases where RBI is seeing that can I set up a network between banks where I have visibility of the transactions that are happening. So I don't need to do a post check. I get immediate visibility of any fraud or any suspicious transactions. Similarly, you have cases of crowdfunding. So with something like Kickstarter, if you have heard of Kickstarter, what happens is that people will come and they'll pay funds for a project, and once the project or the product that is being created is done, it is given to the participants who had funded in the project. But sometimes people might run away with the money. So instead of that, you can write a smart contract where people can contribute funds to, and once the product is created, the product is shared with the people who had invested in the system. Similarly, we are also looking at workflow management and asset ownership with blockchain, like we discussed earlier. So, in the case of diamonds, in the case of land, in the case of securities and assets, stocks, shares, etc., we are looking at using blockchain. Payments is another interesting use case, especially cross-border payments, because while domestic payments, we have UPI, we have NPCI to help us carry out payments. Globally, payments are still extremely expensive and time-consuming in terms of how settlement happens. So payments is another interesting use case where blockchain is being explored, right? Supply chain management is an important use case where manufacturing companies are looking at tracking parts and raw materials across various intermediaries and OEMs and warehouses using blockchain. Several important use cases that participants that various enterprises are working on. These are some of the popular blockchain platforms or tech stacks that are available. So, for example, Bitcoin everyone has heard of, and probably the oldest and the most popular among these blockchain platforms. It's a similar peer-to-peer payment application that allows you to send funds from A to B without depending on a bank or a payment system or Visa, MasterCard, etc. So that's why it's called a peer-to-peer payment system. Like Torrent, if we need to share files, I can share it directly with you without going through someone else. Similarly, in Bitcoin, I can send money directly to you without going through a middleman. Ethereum is probably the second most popular blockchain platform. So it was the first blockchain platform to introduce smart contracts. And while it allows you to send funds and receive funds like Bitcoin, you can also do a lot of interesting things with Ethereum. Like you can write smart contracts. You can, uh, you can trigger event-based dispersal of funds or receiving funds. There are companies that you can run where you don't need a board of directors. You can only take votes from the participants and execute different decisions. So it's probably one of the most dynamic and most interesting blockchain platforms that is out there. Hyperledger Fabric is another open source blockchain platform that is built in conjunction with IBM and the Hyperledger community, which is an open source community under the Linux Foundation. And what they have done is they have taken the core idea of blockchain and they have tried to add a lot of enterprise concepts to it. So concepts like securely storing public and private keys, securely providing identities to participants on the network, working with firewalls, writing secure smart contracts, bringing in containerization, uh, right, creating plug and play applications with different features. So all these are features that are available as part of Hyperledger Fabric because it's a blockchain platform that is broadly focused on enterprise use cases, unlike Bitcoin or Ethereum, which are more focused on public usage. Corda is another popular blockchain technology stack which is created by the R3 consortium. Corda is more focused on financial applications, and as a result, what it tries to do is it tries to use a peer-to-peer ledger for doing faster settlement in trading, faster settlement in payments, for notarization, for a lot of financial use cases. And recently, they have also started to get into a lot of non-financial use cases. So it's again one of the more popular blockchain platform that is there. In fact, Fabric and Corda might be the two most popular blockchain applications for enterprises in the world right now. Similarly, you have Ripple. So Ripple is one of the oldest blockchain platforms that we have available to us. They started with the idea to disrupt Swift, which is a large payment provider globally, and they wanted to build a system that is more robust than Swift and can carry out cross-border payments or international payments at a fraction of the cost. Stellar is similar to Ripple. It all has a lot of features that are similar to Ripple, but unlike Ripple, which is focused on enterprises and banks and remittance exchanges, Stellar is focused more on non-profit ventures. For example, for women's self-help groups, for cooperative banks, for disbursal of subsidies, and so on. Right. So these are probably some of the very popular blockchain platforms that are out there that you can look at. Okay, so now let's come to the last part of our session and then we can open the floor for any questions. So let's look at what kind of career opportunities you can have if you decide to learn blockchain and add it to your skill base, right? So this is a brief snapshot of what kind of industries are working with blockchain. So you will notice that it covers a gamut of industries, right? So I mean, starting from healthcare to media, marketing, legal, government is a big use case, banking and finance is a big use case, cybersecurity is another industry that's working hard with blockchain and exploring how it can be used. Banking and fintech, I've already mentioned. Charities there, automotive and other manufacturing industries are looking at it, and there's a bunch of use cases that they find that are relevant to them. Real estate is obviously there. I mean, land registration we have already discussed. That's one of the oldest use cases, but also in terms of land ownership and property ownership and timeshares, etc., things like that. So almost all industries are working with blockchain and they realize the potential of this technology in the future. If I were to pick some of the industries that are much more ahead of the curve and are working more seriously, so I would say definitely banking, finance, and fintech is working very hard on implementing blockchain into their future applications or into their enterprise stacks. Similarly, governments realize that there's a lot of benefits that blockchain provides to them as a regulator, and it can also help them provide a lot of efficient, it can help them do efficient service delivery for their citizens and you know secure the privacy of their citizens and so on and so forth. So governments are working very hard on integrating blockchain into their IT systems. And lastly, I would say manufacturing is very important. So automotive and other manufacturing and supply chain is very important in terms of what is being done. Okay. And in terms of career roles, so there are broadly three career roles you can look at. So the first is a full stack blockchain developer. So these are essentially developers who are specialized in one or more of the blockchain platforms that we were discussing earlier, like Corda, Hyperledger Fabric, Ethereum, etc. So what you could typically do is you can probably go in for a course or a certification course and get some basics and try your hand out at it. And the reason I call them full stack blockchain developers is that because if you look at how these developers are working, they're essentially experts in much more than blockchain. Because if you look at blockchain applications, the blockchain component or coding the blockchain component is only 20 to 25%. 75% of it is still writing services, creating a web server, creating an application server, setting up a database, creating a front end, things like that. So people who are working in this field are essentially full stack developers who can build an entire blockchain application from scratch. Mostly they'll be specialized in one blockchain platform. So this can be Hyperledger Fabric or Ethereum or both. Corda is also getting very popular, and they will use their skills to build an application from scratch. And right now, the demand for them is especially high, right? So, I mean, enterprises have been looking for blockchain developers, but also startups have been working in this space. A lot of startups in India have clients based out of West and in India, and they are building products for these customers. Recently, with the Supreme Court's decision to, sort of validate that cryptocurrencies are not illegal in India. You have again, we are again seeing a surge of a lot of startups getting into the trading and cryptocurrency space, and it also gives us access to public blockchains like Ethereum and Bitcoin. So, due to these reasons, you will see a lot of these startups are offering high-paying or medium-level jobs to blockchain developers on Ethereum, Hyperledger Fabric, and so on and so forth. Uh, you can also probably look at Bitcoin if you want to work with public blockchains. It's a very niche and specialized field, but since trading is again legalized in India, you might see a lot of startups that are working with Bitcoin as well. Okay. So apart from blockchain developers, the other kind of skill you can look at is solution architects. So solution architects are basically similar to your solution architects for enterprise systems, and they can be technical as well as functional. And it's best if you are both. If you understand, if you have the technical knowledge as well as you understand the business requirement. In the case of blockchain. So these are basically people who are doing the high level to low level design for a lot of blockchain applications that are being deployed right now into a lot of governments and a lot of enterprises. Why their role is important, even more important than the blockchain developers, is because they can look at an enterprise system, or they can look at the requirement of an enterprise or a business and take a call on what kind of product needs to be built, what kind of features needs to be used, and what blockchain stack can be used. So typically people who have had 7 to 9 years of experience with enterprise blockchain and have been working in this field for a long time, they can go in for a blockchain course and then understand the technology, and they can understand a few stacks. So maybe Fabric, Ethereum, and Corda, which are one of the more popular ones. And then you can augment your existing knowledge that is there. Similarly, business analysts or business solution architects who have been working in a certain domain for a long time, such as automobile or pharma or so on, you can uh, quickly learn blockchain technology and then add it to your arsenal for designing products or workflows. So again, blockchain solution architects is, I would say, one of the fields that people are only starting to realize right now. And I would say there's a dearth of people that are specialized in this, and soon we'll see a huge search for professionals who are skilled at this role. The third is entrepreneurs. So there's a certain name that is given to applications that are built on top of blockchain. These are called dApps. So dApps is short for distributed apps. So entrepreneurs can use public or private blockchains for building their own applications and deploy it. If you, let's say you decide to work with public blockchain like Bitcoin or Ethereum, then you can build your own payment platform. People are now again starting to build trading exchanges. You can build, like, there are very interesting messaging systems that use Bitcoin. There are people who are trying to protect copyright laws using Bitcoin and Ethereum. So a bunch of interesting things you can do. You can build your own product from scratch using blockchain if you understand the technology. If you decide to go for private blockchains and build applications for enterprises, you can do that as well. If you understand blockchain and there's a certain domain that you are an expert in, you can definitely uh, create new products or workflows that help you contribute to your domain or sell better products to clients. And lastly, for people who are not freshers or people who have been working with some technology such as cloud computing or databases or enterprise workflow design, etc., you can look at blockchain as simply an additional skill. I mean, I would actually recommend that most people look at blockchain as an additional skill right now, rather than as something that defines your entire professional profile as a whole. The reason for that being that if you look at most blockchain applications that are happening, blockchain plays a very small role. So after you have set up the peer-to-peer network and you have written the smart contracts and deployed it, the people who are actually looking at blockchain at a daily basis are mostly people who are doing the maintenance of it, or ensuring that everything is running smoothly. Everyone else is doing basic application design. So like everything else, Here also you will be working with APIs and SDKs. It's not drastically different or complex compared to the skills you already have. So you can look at blockchain as an additional skill to add to your arsenal. So like you would know, let's say machine learning or databases or cloud computing, you can look at blockchain to work with as well. Okay, right. So with that, I come to a close on my session. If you would want to know more, and if you work in the field of finance, you can also check out my book. It's called Blockchain Development in Finance Projects, and it focuses on 8 projects where basically it takes the user through 8 blockchain use cases in the financial domain, such as payments, trading, uh, cross-border remittances, etc. KYC and so on. And it works with the 3 blockchain stacks, which is Ethereum, Hyperledger Fabric, and Stellar. So if you work in finance, you want to know more, you can check out my book. I think you will find it interesting. It starts from the scratch, and at the end of it, it will help you design 8 unique applications. Right? It's available on Amazon. You can find it from Pact's website, or it's available as an ebook on O'Reilly as well. Right? So with that, I come to a close. If you have any questions, you can put that in the chat window and I can address them now. Okay, so few questions I'm able to see. I'll start taking the questions one by one. So I think 10 minutes can give. One favor if you can do me, if you put a question earlier, if you can just put it in the chat box again. Okay, so I see Dolly Yadav's question, so I'll start with that. Yeah, just a moment. Hello. Yeah. Yeah, sure, sure. Go ahead. Yeah, yeah. Yeah, I'll do that. Yeah, just a minute. I think you guys can put questions into the chat box. I'll just unmute Bala. I think he wants to address you guys as well. Just a moment. Yeah, Bala, you can go ahead.
Hey, thanks, Ishan. Thank you so much. Hey, guys, if you have any question, feel free to post it. Okay. So this is the first webinar that GUVi started after this Corona outburst. So we thought we should make use of everyone's time and we should make them to get skilled in the right technologies. So, and that's when we reached out to Ishan from TNJ, and he gladly helped us and he said, yeah, I'll come and do that. So thank you so much, Ishan. Thanks for actually having us on board in a very short notice of time.
Sure, Bala. It was a pleasure.
Yeah, I've been following the session as well, and it's quite informative. And for the audiences, so this is just a beginning. So this is the first thing that we have started, and obviously there are a lot more to come. Okay, so do stay tuned on this and make better use of this opportunity so that you can actually post more questions, and people can, and I mean the authors can actually let you know about those things because they are the experts in this field. And Ishan has been doing a great job in this field as part of e-governance. And that's when we thought maybe we should the right person to talk about this. Blockchain, many people have been talking about it in theory, but he's one who has actually implemented it. So feel free to ask the questions and do a follow-up session as well. Okay. Hey, thanks, Ishan.
Thank you,
You
Bala.
can answer the questions meanwhile.
Sure. So let me take the questions. I think we have 10 minutes. We can take questions. So let me start with Dolly's question. So Dolly is asking, what is the advantage of storing data as blocks over any other format? So Dolly, it's basically a system design. The idea behind it is that, like we said, that since you have multiple participants, you need to identify a way in which the ledger will be updated. So that's one of the reasons we go for a block, where we say that instead of adding individual transactions and giving a chance to add one transactions, which will be counterintuitive and time consuming, you add transactions in the block to the ledger. Apart from that, there are certain other advantages, because if, let's say, I had to link every transaction with each other like we do a block, that would be very time consuming. It will take a lot of time for the system to work. So what we say is that you add transactions in blocks of 1 MB and you link all of them between. So you get a secure ledger that cannot be tampered. Okay. So Dolly, I hope that answers your question. Yeah. So going back to, okay, so going back to Realme 5's question, I want to set up a company entirely based on blockchain. So that's a great idea. I'm not sure what's your professional background is, but what you could do is that if you are new to this technology, you probably spend around 3 to 4 months learning from some certification courses and online material. And once you understand it, and if you have previous IT experience and you have some understanding of a domain, so typically the best way to approach this technology is to pick a domain and then work in that field, because domain knowledge is very important for designing blockchain applications. So let's say, assuming you work in pharma, you can use your knowledge of pharma and pharma applications to build blockchain products. Okay, so Harsh, if you're a student, uh, how to design a smart contract for renting property. Okay. So Harsh, what I would say is that you can probably go for a Ethereum course or a Fabric course to first understand how smart contracts are written, right? So get a understanding of languages like Solidity that can be used for writing smart contracts, and probably look at some applications of how you can build asset provenance for properties on blockchain. Okay. So I hope that answers your question. Okay, let me just start. Okay, so Vicky Surya's question is, most cryptocurrency exchanges use P2P. So since cryptocurrency exchanges are trading with Bitcoin or Ethereum, these networks are P2P. So Bitcoin is P2P and Ethereum is P2P, or Litecoin, any network you can think of, it's a P2P network. So that's why, yes, the answer is yes, they use P2P networks. Okay, so moving on. Just a minute. Okay, so Vicky's question is how to build an efficient wallet for an exchange, also any other security measures we look into. So Vicky, it will depend on what kind of an exchange you're building. So there are different trading exchange models that are there. So one is that if you have seen something like Zeppay or Coinbase, where you as a house is selling to the customer, right? So in that kind of setup, you will go for a custodian wallet, where basically you you sort of have ownership for the customer and they place their trust on you. However, if you want to build something that is more secure and something for the more advanced customer, you can look at something like MetaMask, or there's something called Jack's wallet. So these are wallets where the private key is with the customer and they are able to control how they are sending transactions or receiving transactions. You already build an application that they can use. So there are two approaches you can take, and if let's say you choose to build the wallet and control the accounts, then you need to make sure that a secure setup is there for keeping the keys safe where they can stored and be retrieved in time. So Vicky, I hope that answers your question. Okay. So Harsh's question I've already answered. Arijit Mahapatra, I am from an ERP background and basically a developer. How to start with blockchain? So Arijit, you are probably the guy who is perfect fit for blockchain because you've worked with SAP systems. So to start with blockchain, you can probably, if you're going to do self-study, you can start with Hyperledger Fabric, I would recommend. And what you can do is you can get a basic understanding of the tech stack and what it does. And even though my book is not a great example for you, but there are use cases like cross-border remittances or corporate remittances, which are very similar to how you guys carry out ERP. Alternatively, you can search the internet for manufacturing or supply chain use cases in blockchain, and there are a bunch of Medium articles and small GitHub projects available, and you can go through that to get an understanding of how people are using this technology in manufacturing and with ERP systems. And then you can probably bring that knowledge back to your domain, your manufacturing domain, and make some suggestions to your employers or build your own product. So I hope that answers your question, Arijit. Right. So how can you be in touch? So you can find me on LinkedIn. If you do a quick search on LinkedIn, you can connect with me and we can discuss anything offline as well. Okay. Great. So I think I've answered everyone's questions. So we'll bring the session to an end. Okay, Arijit. So Arijit, to answer your question, you should start with Hyperledger Fabric. Okay. Well, Corda is also a good example, and if somebody from RG Corda is in the call, they'll tell me why are you not suggesting Corda. But I would say maybe try with Fabric because for manufacturing it might be slightly more suited. Okay. All right. Just quickly search for Ishan Roy. So you can search with my name, and you'll find me on LinkedIn. Okay. All right. Thank you, guys. If there's no other question, let's bring the call to an end. Thank you for joining. It was a pleasure. Have a nice day.